Okay, in problem number 22, we have a rational function 1 over x squared, and we're looking for the derivative f prime of x of the function 1 over x squared. So we start as always with the limit as delta x approaches 0 of f of x plus delta x minus f of x and all over delta x. And now we're ready to start plugging in. So wherever we see x in the original function, we're going to substitute x plus delta x. So we have the limit as delta x approaches 0 of 1 over x plus delta x quantity squared, then minus 1 over x squared, and all divided by delta x. When we have this kind of rational function where we have a numerator with a complex fraction, we call the whole thing a complex fraction because it's fractions within a fraction. And we're going to need to multiply the top and bottom by the least common denominator in the numerator. So in this case, that is x squared times x plus delta x quantity squared. And we'll have to multiply top and bottom by that. And we're going to distribute that in the numerator to each of those two terms. And because we're using the least common denominator there, or the least common multiple of those two, our fractions are going to go away. So we have x squared times x plus delta x quantity squared over x plus delta x squared. So we're going to apply that, and we end up with the x plus delta x squared canceling, leaving only x squared. Then we're going to do the same thing and multiply times 1 over x squared, and there the x squares will cancel and we'll get minus the quantity x plus delta x squared, and then all over delta x times x squared times x plus delta x squared in the denominator. Now I'm going to expand out the numerator, but I don't want to multiply anything out in the denominator because I'm going to start to cancel things out, especially that delta x. If I multiply it through, then it's going to make my life more complicated. So the numerator is going to multiply out as x squared, which we had. Then we'll have minus, and I'll expand that out in parentheses because of the negative sign in front. X squared plus 2x delta x plus delta x squared. First term squared, multiply them, x times delta x, and double it, plus 2x delta x plus delta x squared. And that's all over delta x times x squared times x plus delta x squared. Now when we do this, our numerator, and we apply that negative sign to everything in the numerator, we're going to end up with limit as delta x approaches 0, x squared minus x squared minus 2x delta x minus delta x squared. And that's all over delta x. Now once again, anything that doesn't have a delta x should disappear, and the x squared minus x squared does. And leaving limit as delta x approaches 0, I'll factor out a delta x. Yeah, I can't forget that. When I wrote up at the top, I forgot to put that in. Alright, so in the numerator I factored out a delta x, leaving me negative 2x minus delta x. And once again, all over delta x times x squared times x plus delta x squared. The delta x factors cancel. I can only cancel the factors. I can't cancel just the random delta x's added and subtracted inside. Alright, so that leaves me with limit as delta x approaches 0 of negative 2x minus delta x over x squared times x plus delta x squared. Now when I set the delta x's to 0, my denominator won't become 0, and I'll have negative 2x in the numerator, and in the denominator I'll have x squared times x squared, or x to the 4th power. And now I can cancel one x in the numerator and one in the denominator, leaving me with negative 2 over x cubed. And that is the derivative of 1 over x squared, using the limit definition of the derivative in Chapter 2, Section 1. We'll go on to the next problem in the next video.